Topic is graphing sine.
Sinusoidal waves. So this is the parent function for a sinusoidal wave. It is f of x equals sine of x. In degrees, this would look like this graph right here. This whole thing here is called a period. You have two periods in this sinusoidal graph. This is what it will look like in radians. Here, you see it starts at 0, just like the degrees graph. Then it goes to 2 pi, and negative 2 pi, so negative 360 pi. Negative 360, excuse me, and 360. Because those are equivalent on a unit circle. So over here, we have the main ideas. So a horizontal translation is f of x equals sine of x plus pi. And this will be a little example of what it looks like. So if it's plus pi, that means it's moving to the left, pi. So then, instead of starting at 0, it starts at negative pi. This would be negative 3 pi, this would be pi, and the midpoints in between would be affected as such. A vertical translation does the exact same thing as you would expect, but vertically. So it's sine of x plus 3. That's not, that's it. So instead of starting at 0 here, you start at 3. So instead of 1 up here, it's 4, and negative 1 out here, it's 2. This is a horizontal dilation. So that looks like sine of x over 2. So this would be a horizontal dilation of 2, as we're used to. So that basically, it speeds the periods up. So you get, instead of here, so you have 0. But instead of 2 pi, negative 2 pi, you just have pi, negative pi. And we'll talk about that a little bit later on. And this is a vertical dilation. So that'll look like 3 sine of x. And then, as you would expect, it starts at 0, but instead of going 1 and negative 1, it goes 3 and negative 3. So down here is amplitude. First, I guess we should talk about this equation first. So this is the base equation for sinusoidal waves. So you get f of x equals a times sine of b times x minus c plus d. So looking at what all those are, we see a, look at example 5 to see what it is. A is the amplitude, so that's basically the vertical dilation that we're used to. And B is the period, and the period's a little special, so it has its own equation. It goes period equals 2 pi over b. So for example, if this was like 2 here instead of a b, say, okay, well, period is 2 pi over b, so I'll put 2 pi over 2, so the period's pi. That's what that tells you. Then over here, it says go to 7, so that's c. So c equals negative 1 times the starting point of the x-coordinate, because you minus it if it's to the right, you add it if it's going to the left. So that's basically going to be like, if you look over here, that's basically going to be like, if it starts here, but if you minus 90 degrees, it'll go here. If you plus 90 degrees, it'll go here. And then the D is for axis. So that is the vertical translation. So that tells you the middle point of the entire graph. So if you would add 1, the entire graph would move up 1. So then instead of the axis being 0, the axis would be 1. Okay, let's be quick. Go.
So for our first example, we're going to have to graph that equation. Based on what Ben has given us, these are all the properties for this graph. So first, the starting point is at negative pi. So just plot that line right here. That's the starting point. And then after that, the period, which is pi. So you're just going to add pi to negative pi. So that's 0 for over here. And then subtract pi, so that's negative 2 pi over here. Now for the y-axis, since the axis is 4, the x-axis is going to be labeled y equals 4. Now for the amplitude, it's this distance from the axis to the midpoint or max point. So you're just going to add 3 and subtract 3. So over here, you're adding 3, so that's 7. Subtract 3, that's 1. And now, since there's also a y-axis reflection, which is shown with that, you're going to start down here, you're going to go up, you're going to go down, and over here you're going to go up, and then now you're going to go down.
Then moving on to the bottom one, it says write an equation for this. So moving on to the bottom one, it says write an equation for the sine graph. So here's the graph right here, and we already have the equation. And now we're going to explain to you how we got that equation. So it goes from negative 1 up to 4 and down to negative 6. So the amplitude is 5. Then the B, it looks like a normal 2 pi period, so the B is just 1. The C, it starts to the right pi, so the C is pi. And then D, the axis is at negative 1, so the axis is negative 1.